Okay? It's using the machine as the kind of, because running on the machine, it has to go to the machine or the computer. Okay? So, what communicates actually processes. These are the entities that communicate. Okay? So when you look at from the layering point of view, you have the data coming from the application, right? You might have heard of the headers, right?
Mm-hmm.
So the data coming from the application is attached first to the transport layer header. So what is the key item that is in a transport layer header?
The offset.
Huh?
Offset.
You need to identify the end processes, right? So you need to use what? Port numbers.
Port number, yeah.
So you have a source port number and destination port number. Several other fields in the transport layer header, right? What are examples for transport layer protocol?
80.
UDP and TCP.
TCP.
For transmission control protocol, UDP user datagram protocol, right? So you have a source port number that identifies the source process, and the destination port number that identifies the destination process. So if you're running say FTP runs on port number
80.
80 is HTTP.
Okay.
Well, FTP is 21. Okay. Your secure shell SSH is 22. Telnet 23. So if you go for interviews, it asks for well-known port numbers, at least 4 or 5 port numbers you should remember. Okay. The well-known are FTP 21, HTTP is 80. DNS domain name service is probably 63 and so on. Okay. So this is the transport layer header along with the data. We have a name for that. It's called the segment. Okay. So you can use the terminology called segment to indicate the data plus transport layer header. And as this goes down, okay, so it's basically the data along with the transport layer header that has the port numbers in it. So just because TCP, 85% of the internet uses TCP, so let me just call TCP header. Now on, and then you have to attach a network layer header, and IP internet protocol is the standard protocol running at the internet layer or network layer. So you have again several fields in IP header. The key fields are the source and destination IP addresses. So an IP address is a 32-bit quantity, right? So for example, Jackson State has this 143.132 prefix. So any machine connected to Jackson State network will have this prefix. Okay, so an IP address will have a network part and a suffix part or host part. Okay? So network part and host part. So an IP address is a logical IP address. So if I want to send a message to a machine in Jackson State network, I need to have the 143.132 prefix. Okay? So we have a source IP address, destination IP address, identifying the end host. Okay? So I also sometimes represent using this diagram, giving you the big picture. So if you want to communicate from a process running in say port 21 or 20, any port number, normally you upload something or download something from a file server. So let's say this is something, this port number 21 is the FTP port process running at a destination server side, right? By IP address, you refer to the IP address of the source. Okay, so this may be say 196.10.0.10. This is a class C. I don't want to go into all the class issues here, but this is a class C IP network, right? So its IP address will be something like this. Whereas if I want to connect to a Jackson State network, this is the network address, so its IP address could be something like this. This is actually a web server IP address, right? So this is what I mean by the source IP address and destination IP address. End-to-end machines IP addresses, alright? And the port numbers, right? So now when this is sent down to the link layer, still you are at the source. right? The source means what? The sending machine process, right? So what you attach with this is a frame header. A frame header is what? It has the MAC addresses. So what I mean by a MAC address? Hardware address. So in this case, when I'm trying to send from the source to the destination, what represents the source MAC address and destination MAC address?
Encapsulate.
When I'm trying to send from here to here, the source to destination, and I said all these things are happening at the source. So what represents the source MAC address and destination MAC address? It is the hardware address or the network interface address of this interface where the source is connected to this network and where this next hop router is connected to this network. So it's basically the MAC address of this router connected to this network and this source. Okay? Because to send from here to here, the packet cannot jump. It has to go through physically from here to here all the way, right? So it has to be physically transmitted or sent from this interface to this interface. So that's why a MAC address or hardware address is also called a physical address, right? So this is what is the frame. And then in the physical layer, you kind of have to encode all this thing because these are all what in bits, binary, right? When you send physically, you have to encode a signal. If you're sending as electrical signals, you have to encode as light electrical signals, or using optical fiber, you have to use optical pulses and all those things, right? So that is handled with a physical layer. So when this message, the data, the whole thing is called now a packet or a frame, right? It goes to this router. It looks at its address to itself, the destination MAC address, removes this frame header, looks at its routing table and decides that if I want to send to this destination IP address, the next hop is this route. And then it has to now send physically from where? From this interface to this interface. So the packet has to physically go on this network. So now it has to now put a new MAC frame header. It has what? The source MAC address corresponding to this interface and destination MAC address corresponding to this interface. So then only the frame can go physically from here to here. And then when the packet gets here, the router has to again accept this, look at the destination IP address. Always routing is based on the destination, where you are going. Even when you are traveling in the airports, you may be coming from different cities. But if you want to go to a particular city, you are put on a plane that goes towards that city, right? So in a hub like this, that's what happens, isn't it? You're always routed towards the destination. So always packets are forwarded towards the destination. Okay, so routing is based on the destination IP address. So which means when you want to route from here to here, you ought to know what's the next hop and put the corresponding MAC address. So only when the packet reaches the ultimate host, then this IP header is looked at, all the other fields. Until then, the IP addresses are the only things that are looked at. Okay? So only when the packet goes to the destination, the IP header and the other fields, like we have done some fragmentation and all those issues, those things are looked at. And then when it's sent to the process, the sequence number and all those stuff in the TCP header are looked at, and then the data is delivered to the process. Which means at all the intermediate routers, right, you look only at what? The IP header, and depending on what fields, values are set up in the IP header, you decide on the process, on the forwarding issue. And the only thing that changes is the MAC address at every hop. The frame header changes. The IP header does not change. So always the source IP address is this, the destination IP address is this. No other IP address gets inserted in the packet. Similarly, the source port number is always the sending process port number, the destination process port number is this, right? So nothing changes. And they are not even looked at. The TCP header is not even looked at. The only thing that's looked at is the IP header. The only thing that is changed every hop is the frame header. Okay? So this is what happens as you transmit a packet or data from one process running in a machine to another process running in another machine to another network. Okay? So that's the whole course as summarized in 10 minutes. Alright, so but you can go to my website if you really want to learn more or to understand the network security chapter.